This is an audio-visual presentation on number bases. Numbers are usually written in base 10 or the decimal numeral, but can be converted or written in other bases as well. To indicate that a base other than base 10 is being used, a small subscript is added after the number. Hence, 42 subscript 5 indicates that the number has been written in base 5 and is read as 42 base 5. That is 42 base 5. That is how it's read. 42 base 5. The base is a subscript to the number itself. The base is a subscript to the number itself. So 42 base 5. That is how it's read. 42 base 5. Now note, base 10 is also known as the decimal numeral. Base 2 is known as the binary numeral. Base n has n digits, starting from 0 to n minus 1. Now, we said base n has n digits, starting from 0 to n minus 1. So base 7 has 7 digits. Base 7 has 7 digits. That means n is equal to 7. And so n minus 1 will be 7 minus 1. That is 6. So base 7 has 7 digits, starting from 0 up to 6. So we have 0, 1, 2, 3, 4, 5, 6. And now when you count, we have 1, 2, 3, 4, 5, 6, 7. So you have 7 digits. Now base 8 has 8 digits, starting from 0 to n minus 1. That is 7. So we have 0, 1, 2, 3, 4, 5, 6, 7. Now let's look at how we can convert numerals from other bases to base 10. How we can convert numerals from other bases to base 10. Example 1. Convert 243 base 5 to a number in base 10. Convert 243 base 5 to a number in base 10. Now solution. Given 243 base 5 to convert to a number in base 10. The digits are 2, 4, and 3, and the base is 5. So we are going to multiply the digit by the base, one after the other. So we have 2 times 5, and that's 2 times 5 in bracket, plus 4 times 5, and that's 4 times 5 in bracket, plus 3 times 5. So we have 3 times 5. Now, after multiplying the digit by the base, what we do is to raise the base to an exponent, starting from 0, from the right hand side to the left hand side. And so we raise the base to an exponent from the right hand side to the left hand side, starting from 0. So we have 0, 1, 2. Now 2 times 5 square is equal to 2 times 25, because 5 square is equal to 25. 4 times 5 exponent 1 is equal to 4 times 5, because 5 exponent 1 equals 5. Plus 3 times 1 equals 5 exponent 0 is equal to 1. Any number of variable raised to the power 0 is equal to 1. Now 2 times 25 equals 50. Plus 4 times 5 equals 20. Plus 3 times 1 equals 3. 50 plus 20 equals 70. And 70 plus 3 equals 73. So this is equal to 73 base 10. And it's also written as 73. That is 73. 73 base 10 can also be written as 73. This means that 243 base 5 is equal to 73 base 10. Example 2. Convert 567 base 8 to a number in base 10. Now let's look at the solution. Given 567 base 8 to convert to a number in base 10. Here we are now going to multiply the digit by the base one after the other, as we did in example 1. So 5 times 8 in bracket plus 6 times 8 also in bracket plus 7 times 8. Now after multiplying the digit by the base, we now raise the base to an exponent from the right to the left, starting from 0. So we have 0, 1, 2. Now 5 times 8 squared. 8 squared is equal to 64. 8 raised to the power 1 is equal to 8. 8 raised to the power 0 is equal to 1. Now 5 times 64 is equal to 320. Plus 6 times 8 is equal to 48. Plus 7 times 1 equals 7. Now 320 plus 48 plus 7 is equal to 375 base 10. This means that 567 base 8. 567 base 8 is equal to 375 base 10. That is how it's read. 375 base 10. That's how it's read. Now let's look at how we can convert numerals from base 10 to other numerals. Converting numerals from base 10 to other numerals. Example: convert 121 base 10 to a number in base 4. Convert 121 base 10 to a number in base 4. Now we are converting from base 10 to other base. In this case, we are converting 121 base 10 to a number in base 4. Now solution. Converting from base 10 to another base. This is how the solution goes. We have in the tabular form, we have the base, we have the number, and we have the remainder. The base is 4 and the number is 121. The base is 4 and the number is 121. So now 121 divided by 4 is equal to 30, and the remainder is 1. How did you get remainder 1? When you multiply 30 by 4, the answer is 120, and the difference between 120 and 121 is 1. That is the remainder. Now 30 divided by 4 is equal to 7, and the remainder is 2. How do you get remainder 2? When you multiply 7 by 4, the answer is 28, and the difference between 28 and 30 is 2. That is why the remainder is 2. Now 7 divided by 4 is equal to 1, and the remainder is 3. Why is the remainder 3? Because 1 times 4 equals 4, and the difference between 4 and 7 is 3, and so the remainder is 3. Now because 1 is less than the base, we stop here and write it as follows. We have 1, 3, 2, 1 base 4. This means that 121 base 10 is equal to 1, 3, 2, 1 base 4. That is 1, 3, 2, 1 base 4. Now I repeat. We are given the number 121 to convert to a number in base 4. So in tabular form, we have the base, we have the number, we have the remainder. Now starting from 4, that is our base. Now 121 divided by 4. 121 divided by 4 will give us 30. Remainder 1. Because 30 times 4 is equal to 120, and the difference between 120 and 121 is 1. That is the remainder. 30 divided by 4 is equal to 7. The remainder is 2. Why? Because 7 times 4 is equal to 28, and the difference between 28 and 30 is 2, and that is the remainder. 7 divided by 4 is 1, remainder 3. Why is the remainder 3? Because 1 times 4 is 4. And 4, the difference between 4 and 7 is 3. So the remainder is 3. Now because 1 is less than the base now, we stop here and write as follows. We have 1, 3, 2, 1 is 4. So 1, 2, 1 base 10 is equal to 1, 3, 2, 1 base 4. Example, convert 4, 2, 3 base 5 to a number in base 8. That is, we are converting from base 5, that is 4, 2, 3 base 5 to a number in base 8. Solution. The first thing we do is to first change the 4, 2, 3 base 5 to base 10. And how do we change 4, 2, 3 base 5 to base 10? We multiply the digit by the base, one after the other. So we have 4 times 5 plus 2 times 5 plus 3 times 5. Then we now raise the base to an exponent from right to left, starting from 0. So we have 0, 1, 2. Now 5 squared equals 25. So we have 4 times 25 plus 5 exponent 1 equals 5. So we have 2 times 5 plus 5 exponent 0 equals 1. So we have 3 times 1. Now when we multiply 4 by 25, the answer is 100. If you multiply 2 by 5, you have 10. And 3 times 1 equals 3. Now 100 plus 10 plus 3 equals 113 base 10. So when we convert 4, 2, 3 base 5 to base 10, the answer is 113 base 10. Then we now convert 113 base 10 to the number in base 8. So the first thing you have to do is to convert to base 10. After converting to base 10, then you now convert to the base, that is base 8. Now we convert 113 base 10 to base 8. So in tabular form, we have the base, we have the number, we have the remainder. Now the base is 8 and the number is 113. Now 113 divided by 8 equals 14 and the remainder is 1. How do you get remainder 1? When you multiply the 14 by 8, the result is 112, and the difference between 112 and 113 is 1. That's the remainder. Now 14 divided by 8 is 1 and the remainder is 6. How do you get 6? When you multiply 1 by 8, the answer is 8, and the difference between 8 and 14 is 6. And that's how come we have the remainder 6. Now because 1 is less than the base, we stop here and write it in that order. So we have 1, 6, 1. This means that 4, 2, 3 base 5 from the question is equal to 161 base 8. Is equal to 161 base 8. Now solving equations involving number bases. Solving equations involving number bases. Example, solve the equation 243 base x is equal to 73, where x is the base of the number. Where x is the base of the number. Now solution. Given 243 base x equals 73, we need to multiply the digit by the base. So we have 2 times x plus 4 times x plus 3 times x. Then after multiplying the digit by the base, we raise the base to an exponent from the right to left, starting from 0. So we have 0, 1, 2. So now 2 times x squared equals 2x squared plus 4 times x equals 4x plus now x raised to the power 0 equals 1. So 1 times 3 equals 3. This is equal to 73. Now 73 on the right hand side becomes minus 73, that is minus 73 on the left hand side, and this is equal to 0. So we have 2x squared plus 4x. Now 3 minus 73 is equal to minus 70, and this is equal to 0. Now let's divide through by 2 to simplify the equation. Dividing 2x squared by 2, we are left with x squared. Dividing 4x by 2, we are left with 2x. And dividing minus 70 by 2, we are left with minus 35. And this is equal to, when we divide 0 also by 2, we are left with 0. So x squared plus 2x minus 35 is equal to 0. Now, x squared plus 2x minus 35 equals 0 is a quadratic equation. So how do we solve this quadratic equation? Coefficient of the square term is 1. Coefficient of x is 2. And the constant is minus 35. Now, to solve a quadratic equation, you multiply coefficient of the square term by the constant. So because coefficient of x squared is 1, 1 times minus 35 will give us minus 35. Now we search for two numbers. When we multiply, we get minus 35, but when we add, we get coefficient of x, that is 2. Now, choosing 7 and minus 5. Why are you choosing 7 and minus 5? Because if you multiply 7 by minus 5, the answer is minus 35, which is equal to this. And when we add the 2, that is 7x plus minus 5x. This is equal to 7x minus 5x, and the answer is 2x. And we are getting the same term here. So we search for two numbers. When you multiply, you get the minus 35. When you add, you get coefficient of x, that is 2. Now this means that we have x squared plus, in place of 2x, you have 7x minus 5x, because 7x minus 5x is equal to 2x. Minus 35 is equal to 0. Now we factor x out, and we have x plus 7 in brackets. When we factor minus 5 out here, we also have x plus 7 in brackets, all equals 0. Now we have x minus 5 in one bracket. Then since the brackets are the same, we maintain 1. So we have x plus 7, all equals 0. Now this means that x minus 5 is equal to 0. And if x minus 5 is equal to 0, then it means that making x the subject, x will be equal to 5. That is minus 5 on the left hand side becomes plus 5 on the right hand side. Also, x plus 7 is equal to 0. And making x the subject, plus 7 on the left hand side becomes minus 7 on the right hand side. And so the value of x is equal to minus 7. Hence, x equals 5. Since x cannot be negative, the base cannot be negative, so the value of x is equal to 5 and not minus 7. Now let's look at operations on number basis. Operations on number basis. Now 9 is equal to 1 2 base 7. Why is 9 equals 1 2 base 7? How many groups of 7 do we get in 9? We have only one group, and the remainder is 2. Normally we write the remainder first before the number of group. So take note. 15 equals 2 1 base 7. Why is it 2 1 base 7? How many groups of 7 do we have in 15? Is 2. The number of group is 2, and the remainder is 1. So we have remainder 1, the number of group is 2. Now 20 equals 2 4 in base 8. How many groups of 8 do we get in 20? Is 2. So we have 2 groups, and the remainder is 4. So 9 equals 1 2 base 7, 15 equals 2 1 base 7, and 20 equals 2 4 base 8. Now let's look at addition. Example, evaluate the following. I 3 4 3 base 5 plus 1 2 3 base 5. I 6 2 4 base 7 plus 3 5 4 base 7. Now let's look at the solution. 3 4 3 base 5 plus 1 2 3 base 5. Now 3 plus 3 equals 6, and 6 in base 5. We write the remainder first. The remainder is 1, and the number of group is 1. Now 4 plus 2 is 6. 6 plus the number of group, that is 1, will give us 7. And 7 in base 5. The remainder is 2. And the number of group of 5 in 7 is 1. Now 3 plus 1 is giving us 4. So 4 plus the 1 group will give us 5. And 5 in base 5, the remainder is 0. And the number of group of 5 in 5 is 1. And that is the 1. So we have 1, 0, 2, 1 base 5. Now II. 6, 2, 4 base 7 plus 3, 5, 4 base 7. Now 4 plus 4 equals 8. And 8 in base 7. The remainder is 1 and the number of group is 1. 2 plus 5 equals 7 plus the 1 group equals 8. And 8 in base 7. The remainder is 1 and the number of group is 1. Now 6 plus 3 is equal to 9. 9 plus the 1 group left will give us 10. And 10 in base 7. The remainder is 3 and the number of group is 1. So we have 1, 3, 3. We have 1, 3, 1, 1 base 7. That is 1, 3, 1, 1 base 7. Now let's look at subtraction. Evaluate the following: 3, 1, 2 base 5 minus 2, 3, 2 base 5. II 5, 1, 3 base 7 minus 3, 6, 1 base 7. Now let's look at the solution. This is subtraction of number bases. Now 2 minus 2 is equal to 0. 3 from 1. We are subtracting 3 from 1. And because the number 3 is bigger than the 1, we need to borrow 1 from 3. Because we are working in base 5, the 1 we are borrowing is equivalent to 5. So we add a 5 to 1, giving us 6. Now, when we subtract 3 from the 6, we are left with 3. Take note that because we borrowed 1 from 3, we are left with 2. And 2 minus 2 will give us 0. And that is why we have 3, 0 base 5. Now, II. 5, 1, 3 base 7 minus 3, 6, 1 base 7. Now, when we subtract 1 from 3, the answer is 2. Subtracting 6 from 1, because 6 is greater than 1, we need to borrow. And what you are borrowing, because we are working in base 7, what you are borrowing, the 1 we are borrowing is equivalent to 7. So when we add 7 to 1, we have 8. Now, when we take 6 from 8, the answer is 2. Now take note that we've already taken 1 from the 5, so we are left with 4. When we take 3 from 4, the answer is 1. So we have 1, 2, 2 base 7. Now multiplication. Evaluate the following: I 2, 3 base 5 times 1, 3 base 5. II 4, 5, 3 base 7 times 1, 2, 3 base 7. Now let's look at how we multiply number bases. Now giving 2, 3 base 5 times 1, 3 base 5. We have 2, 3 base 5 and we have 1, 3 also base 5. Now 3 times 3 is giving us 9. And 9 in base 5. The remainder is 4. And the number of group of 5 in 9 is 1. So now we keep the 1. 3 times 2 is 6. 6 plus the 1 will give us 7. Now 7 in base 5. How many groups of 5 do we have in 7? Is 1. And the remainder is 2. So we have the remainder 2 and the number of group is 1. Now 1 times 3 is equal to 3 because it's not up to the base. So you write the 3. 1 times 2 is equal to 2 because it's not up to the base. You write the number 2. Now after multiplying, we now add. So we have 4. Because it's not up to the base, we write the number 4. Now 2 plus 3 equals 5. And 5 in base 5. How many groups of 5 do we have in 5? Is 1. The remainder is 0. So we have 0 and we keep the 1. Now 1 plus 2 equals 3. 3 plus that 1 group is 4. And because the 4 is not up to the base 5, we write 4. So we have 4, 0, 4 base 5. That is when we multiply 2, 3 base 5 by 1, 3 base 5. The answer is 4, 0, 4 base 5. Now, with the example in II, we are given 4, 5, 3 base 7 to multiply by 1, 2, 3 base 7. And I give this to you as an exercise to solve. That is, multiply 4, 5, 3 base 7 by 1, 2, 3 base 7. The answer is 6, 3, 0, 1, 2 base 7. So try and see if you can multiply 1, 2, 3 base 7 by 4, 5, 3 base 7 to get 6, 3, 0, 1, 2 base 7. Now let's look at the alternative approach. From the question, we are asked to find 2, 5, 3 base 7 times 1, 2, 3 base 7. So we need to convert 4, 5, 3 base 7 to base 10. Then we also convert 1, 2, 3 base 7 also to base 10. Now, how do you convert 4, 5, 3 base 7 to base 10? We need to multiply the digit by the base. So we have 4 times 7 plus 5 times 7 plus 3 times 7. Then we raise the base to an exponent from the right to the left, starting from 0. So we have 0, 1, 2. Now 7 squared is equal to 49. 7 raised to the power 1 equals 7. And 7 raised to the power 0 equals 1. 4 times 49 is equal to 196. Plus 5 times 7 equals 35. Plus 3 times 1 is equal to 3. So 196 plus 35 plus 3 is equal to 234. That is 234 base 10. So 4, 5, 3 base 7 equals 234 base 10. Now we also convert 1, 2, 3 base 7 also to base 10. We also convert 1, 2, 3 base 7 to base 10. So converting 1, 2, 3 base 7 to base 10, we also multiply the digit by the base. We multiply the digit by the base one after the other. So we have 1 times 7 plus 2 times 7 plus 3 times 7. After multiplying the digit by the base, we raise the base to an exponent from the right to the left, starting from 0. So we have 0, 1, 2. Now 7 squared equals 49. 7 raised to the power 1 equals 7. And 7 raised to the power 0 equals 1. 1 times 49 equals 49. Plus 2 times 7 equals 14. Plus 3 times 1 equals 3. Now 49 plus 14 plus 3 is equal to 66. That is 66. This means that 1, 2, 3 base 7 is equal to 66 base 10. That is 1, 2, 3 base 7 is equal to 66 base 10. Now 4, 5, 3 base 7 is equal to 2, 3, 4 base 10. And 1, 2, 3 base 7 has also given us 66 base 10. And so from the question, we are supposed to multiply 4, 5, 3 base 7 by 1, 2, 3 base 7. And therefore, because we've now converted to base 10, we multiply 2, 3, 4 by 66. So 2, 3, 4 times 66 is equal to 15444. Now, when we multiply 4, 5, 3 base 7 by 1, 2, 3 base 7, that is after converting to base 10. We now multiply 2, 3, 4 by 66, and the answer is 15444. Now we have the base because we were working in base 7, so the base is 7. We have the number is 15444, and the remainder. Now 15444 divided by 7 equals 2206, and the remainder is 2. 2206 divided by 7 equals 315, and the remainder is 1. 315 divided by 7 is equal to 45. That is 45, and the remainder is 0. 45 divided by 7 is equal to 6, and the remainder is 3. Now because 6 is less than the base, we stop here and write the numbers as shown by means of the arrow. So we have 6, 3, 0, 1 2. So 453 base 7 times 123 base 7 is equal to 63012 base 7. This is the end of our presentation on number basis.